Hi, Professor. My name is Manpreet Singh Samra. I hope you are doing good. So today I'm here to share you my assignment three, house price competition. As per this, we have to make it's a competition basically, and we had to do our code and we had to comment our code as well. It's a lot, so I'm really sure like it's gonna be more than 5 minutes of video because I have to explain everything. So without further delay, let's get started. So first of all, I forgot like I have to write my name and my student ID. Okay, so here is me. So let's start with the assignment. So now over here in the first cell, I started by importing four essential Python libraries because each of them serve a unique purpose in data analysis. First is pandas, as we know. This is fundamental for data manipulation and handling structured data, like we use it for last two assignments as for last assignment as well. Next is NumPy. Why it is a widely used library for numerical operation. Um, it like complements Panda by providing the mathematical function and tools for working with the arrays and matrices basically. And after that, we have matplot.pyplot. This is you helps in creating visualizations, bar graphs and everything. And after that, we have Seaborn. It is a visualization library which is designed for like statistical plotting. Um, so like after this, I loaded the training data set and my testing data set. Okay. Further, so this is basically for my matplot.pyplot for plotting the graph of the testing and training CSV file, which is over here. So here I have set the size of the plot to make it clear and visually appealing, which is a width of 10 units and height of 6 units, as you can see. Um, Then I have used Seaborn's hist plot over here to create histogram of price column. Then the KDE is equal to true option. This overlays the kernel density estimation, which is called KDE, curves on the histogram and provides smooth representation of data distribution. So basically, this is all we have done in the last two assignments as well. So I will not be focusing that much. So like in this segment, I am I have made comments here too, but still I'm identifying and analyzing the columns in the training data set that are missing. Those are like have missing values. It's like a very essential step in data pre-processing. And here training data dot null parentheses, it creates a data frame of the same shape as trained data, which contains true if the value is missing and false otherwise. Mean is calculating the mean of the like true false values column wise. Like true is treated as 1 and false is 0. Times 100 means I multiply the result by 100 and convert those proportion into the percentages missing values greater than 0. This means like I filter out the columns where the percentage of missing is 0 because I'm only interested in the missing data. And sort value, the remaining columns are sorted in the descending value of missing proportions and with the most missing data. After this, here, um, here I'm addressing basically the missing values in the training data set by filling them with appropriate stats based on the data type of each column. So proper handling of missing data ensures that the data set is basically ready for analysis and model training. So I have written like training data dot select d type. So This selects all the numerical columns from the data set for column N. I I would say this thing iterates over the numerical column names and the line over here. For each numerical column, I replace the missing values with the median of the column. So, and the median is used because it is close to the outliner, then it gives more, accurate and value skewed data. And after that, these are same for the missing the column, the categorical column. This was in numerical. Okay, now they have printed the thing and it returns zero if all the missing values are handled. So as you can see, it's zero. So successful. Yeah. Now I'm applying the log transformation like this is all the same. Now here I have did this cell in further steps. So like step one basically is define the target variable and select features. And after that, like the features, um, how can I say like I selected the top numerical features for training, like in the previous step, and excluded the sale price column. You can say, yeah. And after the step two is like splitting the data into validation step, and so yeah, like this is all the steps that we did. Um, and here I did like the sale price, which contains the house prices which are gonna be predicted. So see, I have made all the comments for you. Sorry, I'm having some throat issue right now. Features. I selected the numerical features identified as important like in the previous step by while excluding the target variable from the feature set. And after that, I have splitted the training into validation and training sets. So like uh, basically 80% is going to be tested and random state 42 makes sure like this data is split is like same every time the code is run. And here I have initialized and trained a gradient boosting regressor with hyperparameter tuning. Like here, param grid. So like here, param grid, I specify the dictionary of hyperparameters to optimize n estimators, the variable here. The string here is basically is the number of tree in the ensemble. So I have given this values and here number of tree and the step size of updating the weights. Max step is like the maximum depth and here for cross validation. Um, so like grid search CV, I perform like a search over the parameter grid using cross validation. CV5 is a five-fold cross validation used to elevate model performance and scoring. Over here is the negative mean square error MSE, which is used as elevation metric. Then I have like basically trained the data and estimator make sure like the with the best combination for hyperparameters is selected as the final model here with the best combination basically. So like here mean squared error in the step 4. I calculate the mean square error between the actual house prices and predicted prices. So the image is basically like the square difference between prediction and actual values, penalizing larger errors more heavily. And so after that, okay, no problem. So after that. I have prepared the test features basically. So here I have selected same features during the for consistency. It's gonna ensure like the model receive input for the same format it was trained. And here I have used it for missing any values in the test data, replace them with the zeros. And here in the step two, I generated predictions on the data set. Here I have reversed the log transformation. And finally, I have created the summation. I know this is a very long, it's going to be very long video, but as the last step, quickly, I'm going to show you like here. I did this summation.csv and it's giving me like 0.45% score. So that is all. Thank you.